Okay guys, let's begin our discussion over the CBSE pattern question exercises for matrices. The first question says that if 2 times of a 2 cross 2 matrix plus another 2 cross 2 matrix is this given 2 cross 2 matrix, find the value of x minus y. Now obviously you can see the quantity x and see the quantity y which are unknown to you. Somehow by operating these matrices together and equating it with this one, we have to compute the value of x and y, plug it in over here and compute the value of x minus y. This is just nothing but algebra of matrices. It's twice of which matrix? 3, 4, 5x plus 1, y, 0, 1. This is given to be equal to 7, 0, 10, 5. Clear? Once we have written this, you know that how to multiply a scalar to a matrix. This results in another 2 cross 2 matrix with each entry being multiplied by 2 respectively. So first entry here it would be 6, 4 into 2 8, 5 into 2 10 and this is 2x plus 1 y 0 1. This is equal to 7, 0, 10, 5. At both the matrices corresponding entries get added because orders are same, so no problem. 6 plus 1 is 7, 8 plus y, 10 plus 0 is 10, 2x plus 1. This is to be equal to 7, 0, 10 and 5. When two matrices of the same order are equal, that means corresponding entries are equal. So 1 1th entry is equal to 1 1th entry, 1 2th entry is equal to 1 2th entry. That means 8 plus y is equal to 0, which implies y is minus 8. Then you have 10 is equal to 10, that is 2 1th entry equals 2 1th entry and 2 2th entry equals 2 2th entry. So 2x plus 1 equals 5. That means 2x equals 5 minus 1, that is 4, x is equal to 2. So this implies 8 plus y is 0 and 2x plus 1 is 5, which means y is minus 8 and x is equal to 2. The moment you have x and y's value computed, you can very easily compute x minus y, which is 2 minus minus 8 and that is 10. So your answer is that the value of x minus y, if x is the 2 2th element of this matrix and y is the 1 2th element of this matrix, to be equal to 10. Moving on to the next question, we have write the element A23, that is 2/3 element of a 3 cross 3 matrix A, whose elements are described by a certain rule over here. And the rule is that the ijth element is equal to mod of I minus j whole upon 2. If A is given to be equal to Aij 3 cross 3 such that Aij is equals to mod of I minus j whole upon 2. In this situation, if somebody is asking you to compute A23, clearly first of all ensure that 2/3 element lies in a 3 cross 3 matrix. It does, right? In the second row and third column lies the entry which is known as 2/3 element. So this is very much a valid entry sitting inside this matrix. So A23 will be equal to mod of 2 minus 3 whole upon 2, that is mod of minus 1 whole upon 2, which is 1 by 2. So 2/3 entry in this given matrix whose ijth element is described by mod of I minus j upon 2 is equal to 1 by 2. Next you have A is given to you to be symmetric and you are asked to find out the value of small a and small b, where this is your small a and this is your small b. Now A is a 3 cross 3 matrix given to you, 0, 2b, minus 2, 3, 1, 3, 3a, 3, minus 1. The moment I say that A is symmetric, that means what? That if you find out the transpose of A, it comes out to be exactly equal to A itself. Transpose is equal to A itself. A transpose will be what? First row becomes the first column, 0, 2b, minus 2, 3, 1, 3, 3a, 3, minus 1. This is A transpose and A is what? 0, 2b, minus 2, 3, 1, 3, 3a, 3, minus 1. So this is equal to this is A transpose, this is A Whenever two matrices of same order are equal, that means their corresponding entries are equal. So 0 is equal to 0, 3 is equal to 2b, that is 1/2th element, 1/2th element of A, this is 1/2th element of A transpose, and this is 1/2th element of A. They both will be equal, so you get 3 is equal to 2b, or B is 3/2. After this you have 1/3th element equals 1/3th element. This is 1/3th element of A transpose. This is 1/3th element of A. They both will be equal because each of the corresponding entries are equal when the two matrices of the same order are equal. So 3A will be equal to -2, or A is -2/3. Fine. A is -2/3, B is 3/2. That is it. Rest everything you can see. If from here also you see 2b equals 3, b will be 3/2 only, and from here if you see 3a equals -2, again a will be equal to -2/3. So either from here you can evaluate, or from 1/2th and 1/3th element you can evaluate. Your a and b are going to come out to be this itself. After this we have to move towards the fourth question. Comes for 2 marks. If A is a skew symmetric matrix of order 3, then prove that determinant of A is 0. Now this is a generalized question. A specific matrix A is not given to you. It's just given that A is a square matrix, which is skew symmetric matrix of order 3. So A is Aij 3 cross 3. That is, matrix A's ijth element is denoted by small aij, where I is varying from 1 to 3 and j is varying from 1 to 3. That's how you write it. It's a generalized matrix. It's given to be skew symmetric. Symmetric means when the transpose is equal to the matrix itself, and skew symmetric means when the transpose is equal to the additive inverse of the matrix. So A is, as A is a skew symmetric matrix, this implies that the transpose of A is equal to additive inverse of A. Now, if transpose of A is equals to additive inverse of A, that means these two matrices are same, that means their orders are same obviously. If A is a square matrix, A transpose is also square matrix of order 3 itself, and negative of A is also square matrix of order 3 itself. Apart from their orders being same, one more thing which we deduce when the two matrices are equal is that the corresponding entries are same. This means that A transpose matrices ijth element is equal to minus A's ijth element for all I, j varying from 1 to 3. Now, if capital A's ijth element is small a ij, then A transpose's ijth element is capital A's jith element. We know that capital A's jith element is small a ji, which is A transpose's ijth element, right? That is what is the relationship between A and A transpose, and this is what minus A's ijth element is minus of A's ijth element. Fine. This is for all I, j varying from 1 to 3. We have to show that determinant of A is 0. Now till here we have arrived. If I talk about determinant of A is skew symmetric, I am already given that A transpose is equal to minus A. So if A transpose is equal to minus A, not just are their orders same, not just is this the relationship between the elements of them, but also determinant of A transpose will be equal to determinant of minus A obviously. If two matrices are same, then the determinants are same, both are square matrices of the same order. I know determinant of A transpose is same as determinant of A, and I also know determinant of K times A is K to the power n determinant of A if A is a square matrix of order n. So therefore, A is a square matrix of order 3, minus 1 is acting as K, minus 1 will be extracted out from each row, there are 3 rows, so minus 1 to the power 3 determinant of A, which means determinant of A equals minus of determinant of A, which means determinant of A plus determinant of A is 0, so determinant of A is 0. Hence proved. We have proved that whenever A is a skew symmetric matrix of order 3, then its determinant is equal to 0. After that, it's given A is this matrix for what values of alpha is A identity matrix. Now, A is a square matrix of order 2. A will be identity matrix of order 2 only when 1/1th entry is 1, 1/2th entry is 0, 2/1th entry is 1 and 2/2th entry is 0. So, A is equal to identity matrix of order 2 if and only if cos alpha minus sin alpha, then you have sin alpha cos alpha is equal to 1, 0, 0, 1, which implies cos alpha equals 1 and minus sin alpha or sin alpha equals 0. You can also say 1/1th entry equals 1/1th entry, that is cos alpha equals 1, 2/1th entry equals 2/1th entry means sin alpha equals 0, 1/2th entry equals 1/2th entry minus sin alpha equals 0 or sin alpha equals 0, which we have already written, or cos alpha equals 1, which we have already written. So, actually for these two matrices to be same, these two things should hold simultaneously, and is written over here. Now, cos alpha is 1, I know when alpha is 0, then cos 0 is 1. Cos 0 is 1, so in place of 1 I can write cos 0. And I also know that sin 0 is 0. So, when alpha is 0, sin 0 is 0. So, cos alpha is equal to cos 0, sin alpha equals sin 0. This itself means alpha is 0. When alpha will be equal to 0 degrees or 0 radians, then sin alpha will be equal to 0 and cos alpha will be equal to 1, in which situation this matrix will be equal to identity matrix of order 2. After this, we have show that all the diagonal elements of a skew symmetric matrix are 0. Now, again A is given to be a skew symmetric matrix. Let us write down as A is a skew symmetric matrix. Therefore, transpose of A is equal to additive inverse of A. That means, as I had just written, A transposes ijth element is equal to minus A is ijth element for all ij varying from 1 to n if n is the order of A. A transposes ijth element is A's jith element and minus A's ijth element is minus of A's ijth element. If I take A to be like this implies matrix A's ijth element is small a ij. So, matrix A's jith element will be small a ji and this will be minus of aij, and this is true for all ij varying from 1 to n. This is for every entry. If for every entry this is true, that means specifically for diagonal entries also it is true. Diagonal entries means both I and j are equal. This implies aij, or I should better write aii, when j is equal to I, then aii is equals to minus aii for all I varying from 1 to n. If this is the relationship between any elements, any I and j varying from 1 to n, then specifically for I and j equal to each other also it is true. That means for all diagonal entries this relationship is holding, which implies aii plus aii, which is twice of aii, is 0, which implies aii is 0 for all I varying from 1 to n, and aii is 0 itself means that a11 is 0, a22 is 0, a33 is 0 and so on, ann is 0. That means all the diagonal elements inside the square matrix, which is skew symmetric, is 0. So, that is how you have proved it. Next we have find a matrix A such that this into A is given to you to be equal to the other matrix. Now, please understand this matrix is of order, what is the order? 3 rows 2 columns, so it is 3 cross 2, and this resulting matrix is again of order 3 cross 2. What should be the order of A? 3 cross 2 is conformable to be taken product with a matrix of order 2 cross something, and 2 cross something, whatever comes over here, 3 cross this is the order of this matrix. So here 2 is already here, 3 cross 2, so here it has to be 2. Because if this is not equal to 2, 3 cross 2 matrix will not be conformable to be multiplied with matrix A, and if here 2 is not there, then 3 cross 2 multiplied by a 2 cross something matrix will not be able to result in a 3 cross 2 matrix. So for it to be conformable, I need this first entry to be 2, and for it to result in a 3 cross 2 matrix, I need the second entry to be 2. So therefore, A has to be of order 2 cross 2, which implies, let me keep A as X, Y, S, T, a random 2 cross 2 matrix. I need to compute matrix A. So I write the relationship which is given to me in the question. It is 2, minus 1, 1, 0, minus 3, 4, multiplied by X, Y, S, T. This is equal to minus 1, minus 8, 1, minus 2, 9, 22. Multiply first row, first column, 2x minus s, 2y minus t. Then this is this first row, first column, then first row, second column. Then I have second row, first column, x, just x, and this is just y. Then it is minus 3x plus 4s, minus 3x plus 4s, minus 3y plus 4t. Fine. This is given to be equal to minus 1, minus 8, 1, minus 2, 9, 22. Because both the matrices are equal, therefore I will be equating their corresponding elements. I am getting 2x minus s is minus 1. X is given to be 1. It is coming out to be equal to 1 because corresponding entries are same. If x is 1, you get 2 minus s is minus 1, or 2 plus 1 is s, so s is 3. So you have got s is 3, you have got x is 1. Next you have 2y minus t is minus 8. And you are also getting y is equal to minus 2. If you put y is equals to minus 2, what do you get? Minus 4 minus t equals minus 8, or minus 4 plus 8 is t. Minus 4 plus 8 means 4, so t is 4. Because minus 4 plus 8 is t, that means 8 minus 4 is t, so t is 4. You have got this. Because these two matrices are equal, so their corresponding entries are equal, which has given me the value of x, y, s and t. So therefore matrix A is x, y, s and t. 1, minus 2, 3, 4 is the value of your matrix such that this relationship successfully is able to hold. Next you have for the following matrices A and B, verify that AB transpose is equal to B transpose into A transpose. Let's verify. So it's clearly saying that you just need to verify it, okay? Because this property we know is already true, that AB transpose is B transpose A transpose. Reversal law of transpose is what they are asking you to recall. So A is, if I talk about AB, A is 1, minus 4, 3, and B is minus 1, 2, 1. This is a 3 cross 1 matrix, this is a 1 cross 3 matrix. So this is 3 cross 1, this is 1 cross 3. So eventually you would be getting a which matrix? 3 cross 3 matrix. So this is first row, first column, 1 into minus 1. First row, second column, first row, third column. Second row, first column, second row, second column, second row, third column. Third row, first column, third row, second column, third row, third column. And what will be AB transpose? Transpose will be minus 1, 2, 1, 4, minus 8, minus 4, minus 3, 6, 3. This is AB transpose is equal to B transpose into A transpose, okay. So B transpose into A transpose. B transpose is what? B is a 1 cross 3 matrix. B is a 1 cross 3 matrix. So its transpose will be what? This row is going to become the column -1, 2, 1. And what is A? A is a 3 cross 1 matrix. This column is going to become the row 1, -4, 3. Again you can see this is a 3 cross 1 matrix. This is 1 cross 3, so answer will be 3 cross 3. First row, first column, first row, second column, first row, third column, then 2 into 1, then -8, then 6, then 1, -4, 3. So you can see -1, 2, 1, -1, 2, 1, 4, -8, -4, 4, -8, -4, -3, 6, 3, -3, 6, 3. So you are getting that AB transpose is B transpose, A transpose, hence verified. Clear? Moving on to the next, we have A is given to be this matrix, and it is given to you that A cube minus 6A square plus 7A plus K times identity matrix of order 3 is 0. Find the value of K. Okay. So for this we actually need to compute A cube, A square. A's value is already given to me. I cube I should know. Then I will be computing this entire sum and evaluating one single matrix here that I would be equating with the null matrix of the same order, and therefore in this given matrix I will be having K unknown, which on equating I will be finding the value of. So first of all is A cube. A is given to me as 102, 021, 203. Okay. So if A square I wish to compute, that is A into A, 102, 021, 203. Let's compute. They are conformable for multiplication obviously. 1 into 1 plus 0 into 0 plus 2 into 2. So it is 1 plus 4, that is 5. Then you have first row into second column, 1 into 0, 0, 0 into 2, 0, 2 into 0, 0. Then it is 1 into 2 is 2, plus 0 into 1 is 0, plus 3 into 2 is 6. So 6 plus 2 gives you 8, right? 1 into 2 is 2, plus 0 into 1 is 0, plus 2 into 3 is 6, so you get 8. Then you have second row, first column, 0 into 1, 0, 2 into 0, 0, 1 into 2, 2. Then you have 0 into 0, 0, 2 into 2, 4, 1 into 0, 0. So here it is just 4. Then you have 0 into 2, 0, 2 into 1, 2, 1 into 3, 3. So it is 2 plus 3, that is 5. Then you have third row, first column, 2 into 1, 2, 0 into 0, 0, 3 into 2, 6, 6 plus 2 is 8. Then you have 2 into 0, 0, 0, 0 into 2, 0, 3 into 0, 0. Then you have 2 into 2, 4, this is 0, 9, so this is 13. Third row, third column, 2 2s are 4 plus 0 plus 9, 4 plus 0 plus 9 is 13. This is A square. Now if I wish to compute A cube is A square, this is A square, multiplied by A, which is 102, 021, 203. Let's compute A cube. Okay. First row into first column, 5 into 1 is 5, plus 0, plus 16. So this is 21. Then you have first row, second column, 0, plus 0, plus 0. First row, third column, 10 plus 0 plus 24, this gives you 34. Fine. Then you have 2 plus 0 plus 10. Fine. Second row, second column, 0 plus 8 plus 0. Then second row, third column, 4 plus 4 plus 15. See, 2 into 2, 4 plus 4 plus 15. This is 15 plus 8. Fine. Then you have 8 plus 0 plus 26. So you have 26 plus 8, which is again 34. Then you have 0 plus 0 plus 0. And then you have third row, third column giving you the last entry, 16 plus 0 plus 39. So it is 55. This is a cube. Now, a cube minus 6a square plus 7a plus k times I cube. Let's write a cube minus 6a square plus 7a plus k times I3 is null matrix. A cube you already have as 21, 0, 34, 12, 8, 23, 34, 0, 55 minus 6 times a square. A square is this 5, 0, 8, 2, 4, 5, 8, 0, 13 plus 7 times A is what? 102, 021, 203 plus k times I cube means 100. This is given to be equal to null matrix of order 3. When you add, you know how to add, scalar multiply, right? 6 will be multiplied to each entry, you will get another matrix of order 3 cross 3. 7 will be multiplied to each entry, you will get another matrix of order 3 cross 3. K 0, 0, 0, K 0, 0, 0, K. Then you will be adding everything and you will be equating it to this. So here on the left hand side you will get one square matrix of order 3 cross 3 and here you will be having the null matrix of order 3 cross 3. And what would be that matrix? That matrix is going to come out to be equal to minus 2 plus k 0, 0, 0 minus 2 plus k 0, 0, 0 minus 2 plus k. This is equal to 0, 0, 0, 0, 0, 0, 0, 0, 0. This means minus 2 plus k is equal to 0 from anywhere, which implies k is 2. Clear? So this is how you compute the value of k for this particular question. Using elementary row transformation, find the inverse of the following matrix. This is the given matrix for you. You have to find its very inverse by elementary row column transformation. Let us try and compute the inverse of this given matrix. We have this matrix given as A, which is minus 1, 1, 2, 1, 2, 3, 3, 1, 1. Consider A is equal to IA. That's what we do, that's the algorithm. So now A is minus 1, 1, 2, 1, 2, 3, 3, 1, 1 equals I 1, 0, 0, 0, 1, 0, 0, 0, 1, A. First thing, well, you need to create an identity matrix here. 1, 0, 0, 0, 1, 0, 0, 0, 1 is what you need to create. Minus 1 is already here, let's not disturb it. I will be performing row 2 goes to row 2 plus row 1. When row 1 remains unchanged, row 2 is added with row 1. 1 minus 1, 0, 2 plus 1, 3, 3 plus 2, 5. Here you have 3, 1, 1. Here also 1, 0, 0, this remains undisturbed. Row 2 is added with row 1. 0 plus 1, 1, this is 1, this is 0, 0, 0, 1. 0 is created here. Now I want a 0 here, so I will be taking row 3 goes to row 3 plus 3 times row 1. Row 3 goes to row 3 plus 3 times row 1. So this is minus 1, 1, 2, 0, 3, 5, 3, 1, 1. Now see, 3 is added to minus 3, so 0. 1 is added with 3, so you get 4. 3 into 2, 6, 6 plus 1 is 7. Similarly over here, this is 1, 0, 0, 1, 1, 0, and here 0 is added with 3. 0 is added with 3 times 0, that is 0 is added with 0, and 1 is added with 0, so 1. This is A. Now from here I can say row 1 goes to minus 1 times row 1, so that I can extract this minus 1 out. I will be left with 1, minus 1, minus 2, 0, 3, 5, 0, 4, 7. Minus 1 common from here as well, you get minus 1, 0, 0, 1, 1, 0, 3, 0, 1, and this is A. Now you can clearly see you want a 1 over here, so I will be using row 2 and row 3 to create a 1 at the 2 to th position. Row 2 goes to row 2 minus row 3. Now 1 minus 1 minus 2, this remains unchanged. Row 2 minus row 3, 0 minus 0, 3 minus 4, 5 minus 7, and here it is 0, 4, 7. Here also minus 1, 0, 0, 1 minus 3, 1 minus 0, 0 minus 1, 3, 0, 1. Clear? Now you have this over here. I want a 0 over here, so I will be saying row 1 goes to row 1 minus row 2. So that you get minus 1 minus minus 1, that is minus 1 plus 1, that is 0. So row 1 minus row 2, 1 minus 0 is 1, minus 1 minus minus 1 is 0, minus 2 minus minus 2 is 0. 0 minus 1 minus 2, 0, 4, 7. Again row 1 minus row 2, minus 1 minus minus 2, so minus 1 plus 2, it is 2 minus 1, that is 1, 0 minus 1, 0 plus 1, minus 2, 1 minus 1, 3, 0, 1, A. Now you need a 0 over here, so what I will be doing, row 3 plus 4 times row 2, row 3 goes to row 3 plus 4 times row 2, this is 1, 0, 0, 0 minus 1 minus 2, 0 plus 4 times 0, 4 plus minus 4, 7 minus 8, 7 minus 8 is minus 1, 1 minus 1, 1, minus 2, 1 minus 1, 3 minus 8 is minus 5, 0 plus 4 is 4, and 1 minus 4 is minus 3. Clear? Times A. Now you can do what? Row 2 goes to minus 1 times row 2, so that this minus 1 vanishes and you are left with just a 1. So here you have 1, 0, 0, 0, 1, 2, 0, 0, minus 1 equals 1 minus 1, 1, 2 minus 1, 1, minus 5, 4, minus 3, A. I have just multiplied row 2 by minus 1, so this is 2 minus 1, 1. Now you just need what? A 0 over here. So row 2 plus 2 times row 3. Row 2 goes to row 2 plus 2 times row 3. So here you have 1, 0, 0, row 2 plus 2 times row 3, row 2 plus 2 times row 3, row 2 plus 2 times row 3, and this is 0, 0, minus 1. Here you have 1 minus 1, 1, row 2 plus 2 times row 3. So it is 2 minus 10. 2 minus 10 gives you minus 8. Row 2 plus 2 times row 3. So minus 1 plus 8. That means 8 minus 1, that is 7. And 1 minus 6. That means minus 6 plus 1, that is minus 5. Minus 5, 4, minus 3. And then you just need to do row 3 goes to minus 1 times row 3. This is 1, 0, 0, 0, 1, 0, 0, 0, 1. And this is, here it is A. 1 minus 1, 1, minus 8, 7 minus 5, 5 minus 4, 3, A. You are getting I equals this identity matrix of order 3. So this is identity matrix of order 3. This is your A inverse. A inverse is coming out to be 1 minus 1, 1, minus 8, 7, minus 5, 5, minus 4, 3, and that is what is your answer of getting the inverse of this matrix by elementary row transformation. Okay, I hope you have got the good understanding over these questions. That's it from my side. Thank you.